Hey there everyone, Ramesh here, back again with another important video. In this video you are going to learn how to build RESTful web services using Spring Boot, Hibernate, MySQL database. Well, the most important part of this video is that we are going to use the latest release of Spring Boot. Okay, and so in this course or in this tutorial you are going to learn how to build RESTful web services using Spring Boot, Hibernate and MySQL database. So this is going to be a full course, guys, for developing RESTful APIs with Spring Boot. Okay, in this course we are going to build get, post, put and delete REST APIs from the scratch. Okay, and the most important part of this video is that we are going to use 3-layer architecture. Okay, the 3-layer architecture is widely used architecture in Spring based applications. Okay, we will build a controller layer, service layer and DAO layer in our Spring Boot application. Alright, so if you are a beginner and want to learn how to build a REST APIs using Spring Boot, Hibernate and MySQL database, then this video is perfectly work for you. And we are going to use Postman REST client to test REST endpoints. Alright, without further ado, let's get started. Let's take a look into Spring Boot project architecture. So this is a pretty simple Spring Boot project architecture. We call basically it as 3-layer or 3-tier architecture. Okay, so this is a 3-layer or 3-tier architecture, and this is a widely used architecture in Spring based applications. All right, so look at here, this architecture contains controller layer, service layer, DAO or repository layer. And each of these layers have their own responsibilities. For example, controller layer basically process all the requests that's sent by the client. Okay, and controller layer is also called API layer because we define all the REST APIs inside a controller layer. In Spring based applications, we typically create a controller and we define all the REST APIs in the controller. Okay, the REST API can be get REST API, post, put or delete REST API. Okay, so just remember, controller layer is responsible to process the request can be get request, post, put or delete request. Controller layer is also called API layer. Okay, next come to service layer. Service layer we basically create to maintain all the business logic. So whenever you have a business logic in your application, then make sure that you will create a service layer and you keep all your application level business logic in a service layer. So apart from business logic, if you have any third-party REST API call or any public third-party REST API call in your application, that logic you can keep in a service layer. Okay, just remember, whenever you have business logic in your application, make sure that you will create a service layer. Okay, and you keep all the business logic in a service layer. Next come to DAO or repository layer. Well, DAO or repository layer is responsible to talk with the database, and in this course we are going to use MySQL database. Well, DAO layer or repository layer holds all the database related logic or persistence logic. Okay, so these are the 3 layers that we are going to create in our Spring Boot application. And again, in a controller we call a service, and in a service we call a DAO or a repository. So basically in Spring based applications we inject service class or a service interface in a controller, and we call service class methods in a controller. Similarly, in service class we basically inject a repository or a DAO, and then we call DAO or repository methods in a service class. Okay, so these 3 layers are independent to each other, and then we'll inject the dependencies and we call its methods. All right, it's pretty straightforward architecture that we are going to use in this tutorial or course. And we are going to use Postman REST client to test all the REST endpoints. Okay, so yeah, so let's directly jump into Spring Toolsuite IDE. Let's start building REST endpoints. Let's jump into Spring Toolsuite IDE and let's quickly create Spring Boot project. So there are many ways to create a Spring Boot project. You can either use Spring Initializer to quickly create and bootstrap Spring Boot project. And if you are using Eclipse STS ID, that is Spring Toolsuite ID, then Spring Initializer is already integrated in Spring Toolsuite ID. So you can use Spring Initializer in Spring Toolsuite ID to create a Spring Boot project. Alright, so go to File here and then New and then choose Spring Starter Project. And look at here, this is a Spring Initializer website, right? So if you can see here, this is the URL. Okay, this is the URL of Spring Initializer, and the Spring Initializer is integrated in Spring Toolsuite ID. So instead of going to the browser and accessing this Spring Initializer website to create a Spring Boot project and generate a Spring Boot project and manually import in Eclipse IDE, so what we can do is we can directly create Spring Boot project using Spring Initializer in Spring Toolsuite IDE itself. Okay, so let's go ahead and let's give a project name here, something like Spring Boot backend. Okay, you can give any name, project name that you want, but I will give Spring Boot backend. And then here you can see two types of project, Maven or Gradle. I'm going to choose Maven, but if you have a requirement for Gradle, then you can go ahead and you can choose Gradle over here. And then we are going to choose packaging as a jar here. Okay, because we are going to run our Spring Boot application as a standalone with embedded Tomcat server. That's the reason I'm going to pick up packaging as a jar here. And then Java version, I'm going to choose Java 16, which is the latest release of Java as of now. And you can see here, these are the three JVM languages, and we are going to use Java. So select Java. And group ID, I'm going to give net.java guides, but you can give any group ID that you want. And artifact ID is nothing but our project name, and keep version as it is. And then description, I will just give Spring Boot RESTful web services. And package, I'm going to give net.java guides dot Spring Boot, something like that. So once you are happy with the details, then go ahead and click on next. Now we are going to choose Spring Starter project dependencies. Okay, so look at here, this is Spring Boot version. So always keep Spring Boot version that is default by default provided by Spring Boot team. So this is the default and stable version of Spring Boot version that you can keep as it is. So by recording this video, this is a Spring Boot version that I use 2.5.0, but you may get different Spring Boot version while watching this video. You can use other versions like Snapshot and etc., but these are not stable. So always use a default and stable release of Spring Boot version provided by Spring Boot. Okay, now here we're going to choose the Spring Starter project dependencies. So we're going to develop Spring Boot REST APIs. For that, I'm going to choose here Spring Web Starter dependency. So if you can just mouse over on this selected dependency, you can see the dependency description. So Spring Web dependency we use to build web applications as well as RESTful web services. And Spring Web internally uses Spring MVC. Okay, and again Spring Web Starter dependency internally provides Apache Tomcat as a default embedded container. So we don't have to explicitly add Apache Tomcat dependency to our project, because Spring Web Starter dependency will internally provide Apache Tomcat as a default embedded container. Alright guys, and apart from this, we are going to also use Spring Data JPA in order to interact with the database. So go ahead and just type Spring Data JPA. Okay, so Spring Data JPA is very useful because it reduces a lot of boilerplate code that is required to develop a DAO layer. And Spring Data JPA internally uses Hibernate as a JPA provider. Okay, just remember Spring Data JPA is nothing but it's just abstraction on top of JPA, and it internally uses Hibernate as a JPA provider. Alright, apart from that, we are going to use MySQL. So we are going to choose MySQL JDBC driver. Alright, and if you are using other relational databases like Postgres or Oracle, then you need to choose appropriate JDBC driver. Okay, in our case we are going to use MySQL server, that's why I have picked up MySQL driver here. Alright, great. And apart from that, we are going to use Lombok. Okay, so Lombok is used to reduce boilerplate code such as getter setter methods, constructors, toString, hash code methods, etc. So by Lombok is very useful, guys. It reduces a lot of boilerplate code. So let's say if we have 10 domain entities or Java classes in our project, then we need to create a lot of getter setter methods and constructor for each and every class, right? So in order to writing getter setter methods, constructors, toString, hash code methods, we can use Lombok annotation to reduce a boilerplate code. Alright, just choose Lombok dependency here. So that's it. So just make sure that you have selected Spring web dependency, Spring Data JPA dependency, MySQL driver, and Lombok dependency. So here we have chosen Lombok library, but make sure that you have installed Lombok in your Eclipse STS ID. Okay, so go ahead and click on finish. And if you look at here, Spring Boot project is created successfully in Spring Tools.id. And basically Maven will take some time to download all the dependencies from the internet, and it will set up our Maven project in Eclipse STS ID. So let's wait a couple of seconds. So you can see here Maven will basically download all the dependencies from the internet. Alright guys, our Spring Boot application is successfully set up. Now what we're gonna do is we're gonna add Java 16 to our Spring Boot project. So right click on the project and then go to build path and choose configure build path. Okay, and look at here, by default you can see here JRE 15 is added, but we have chosen Java 16 while creating our Spring Boot project. So let's go ahead and let's add Java 16. Okay, JDK 16 here. So I have already configured JDK 16 in my Spring Tools.id. So I'm going to choose Java 16 here. And if you are using Java 8 or 11, so these releases, these Java versions perfectly work. So make sure that you use Java 8 plus. Okay, so here I am using JDK 16, but you can use JDK 8 or JDK 11, 10, 13, etc. Okay, so go ahead and click on finish. Alright, apply and close. Now if you see here, JDK 16 is added to our Spring Boot application. Alright, this is the first step. We have created our Spring Boot project. Next step is we're going to create a packaging structure for our Spring Boot project. Alright, so go ahead and right click on the main package here, new, and then choose package here. So we're going to create a standard project structure, guys. So go ahead and just give a project, the package name as controller, and we're going to create one more package. Right click on main package, new, and then choose package here, and just give package name as service, and right click on service package, new, and then choose package, and we're going to create a sub package inside a service package, that is IMPL. And go to again main package, right click new, and then choose package, and we are going to create one more package. Let's call it as exception, and let's go ahead and let's create one more package, and let's call it as a repository. All right, now I want to create one more package. Let's call it as model or entity or domain. So different developers give different naming conventions for this layer. So we're going to call it as model. Perfect. So this is the second step. Okay, we have created a packaging structure for our Spring Boot project. The third step is we are going to configure MySQL database in our Spring Boot project. Well, first we need to create a database. So go ahead and open MySQL Workbench. So I'm in a MySQL Workbench. So MySQL Workbench is very popular client to connect to MySQL server. So we're going to create first database. Let's write the statement create database followed by name of the database. I'm going to give a database name as EMS, that is Employee Management System, and I'm going to execute this query. I refresh the schemas and there we go. Employee Management System database is created. Alright, perfect. Now once we create a database, then we are going to configure this database in our Spring Boot project. So go to resources. Okay, within resources we have application.properties file. Now we are going to configure our MySQL JDBC URL, username and password, and Hibernate dilate in this application.properties file. So look at here, we have Spring Boot project architecture, right? And here we have a DAO layer, a repository layer, which will talk with database, and we need a different parameters to talk with the database. We need a JDBC driver, JDBC URL, username and password. So these are the properties we need to configure in our application.properties file. And this JDBC driver is not required anymore, because JDBC 4 onwards, so application will automatically detect the driver class whenever it finds a JDBC driver and a class path. So we need to configure a driver class in our Spring Boot project. So we need these three parameters. Along with that, we need to add Hibernate dilate. Alright, so we're using MySQL database, hence we need to add a MySQL Hibernate dilate. Okay. Let's type the property spring.datasource.url. Okay, so we use this property to configure JDBC URL to connect to MySQL database. Alright, now let's enter a value for this property, JDBC followed by colon and then MySQL, localhost followed by the port of the MySQL server, that is 3306. So this is the default port for MySQL server, followed by the name of the database, that is EMS, Employee Management System, and followed by we are going to provide a property that is to disable the SSL. So just give property as use SSL equal to false. Alright, so look at here. So this is a local host. We are connecting to a local MySQL server. That's why we have used localhost here. But if your database is located on other server, then you can provide that server IP address or host name here. Okay, great. Alright, so this is the JDBC URL to connect to MySQL database. Okay, great. And look at here, this is a MySQL to connect to MySQL database. If you are using other relational databases, then you need to replace MySQL string over there. So similarly, let's configure username password for MySQL database. Just type the property spring.datasource.username, and in my case my username is root. Similarly, let's provide a password spring.datasource.password equals to root. Alright, so my database username and password is root. So make sure that you will replace these two property values. Okay, make sure that you will provide your database username and password. Okay, just remember these changes. And now what we're going to do is we're going to provide Hibernate properties here. Okay, so the important Hibernate property is Hibernate dilate. Alright, so let's go ahead and let's just type the property spring.jpa.properties dot hibernate dot dilate. Okay, so this is the property to configure Hibernate dilate, and followed by just provide the dilate value here. So look at here, org hibernate dilate dot mysql 5 inno.db dilate. So this is the dilate that Hibernate requires to generate, database database related queries. For example, here we are using MySQL 5 InnoDB dilate. Hibernate uses this dilate to internally generate SQL queries for MySQL database. If you are using PostgreSQL database, then you need to use PostgreSQL Hibernate dilate. Okay, so just remember, Hibernate needs a dilate to generate, database vendor specific SQL queries. Alright, just remember what is the dilate. Okay, great. So we need to configure one more Hibernate property, that is Hibernate auto DDL. So this property we need to automatically create the tables in a database. So just type the property spring.jpa.hibernate.ddl auto. So this will create a DDL, that is SQL create statements automatically in database. So here I am using update value for this property because Hibernate will use this property value to automatically create the table if it does not exist. If tables are exist, then it will Hibernate will update the existing table. So this value is very important. You can use other values instead of update value. For example, create or drop. Alright, so these are the configuration that Spring Boot requires to connect to the MySQL database. It's pretty simple, isn't it? Just configure JDBC URL, username, password, and Hibernate dilate. Alright, now what we're going to do is we're going to run our Spring Boot application and let's verify whether our Spring Boot application is able to connect to MySQL server or not. Okay. Okay, yeah, here it is. So look at here, our Spring Boot application is up and running, and you can able to see here our Spring Boot application is up and running in embedded Tomcat server, which is running on port 8080. Okay, it means that we have successfully connected our Spring Boot application to MySQL database. Now let's create JP entity for employee. So let's go to model package, right click on model package, new, and then choose class, and let's give entity name as employee. Okay, so this is the employee management application, so we are going to create employee JP entity. Now let's define few properties for employee entity: private long ID, private string first name, private string last name, and then private string email. Alright, so to keep it simple, I'm going to add these simple properties to employee entity. Okay, now we're not going to create a getter setter methods, constructors, and toString method. In fact, we are going to use Lombok annotation, that is add data Lombok annotation. So Lombok is very useful Java library which will reduce a boilerplate code. So look at here, if we dive into data annotation, it internally uses few annotation. For example, look at here, it internally uses add getter, add setter, add required argument constructor, toString, equals, and hash code. So add data annotation internally uses all these annotation to generate required methods. For example, getter setter methods, constructor, toString, equals, and hash code methods. Perfect, right? Okay, now you can see here employee is simple Java class. and we need to make this Java class as a JPA entity. For that, we are going to use JPA annotation. Okay, so let's go ahead and let's use JPA annotation to make this class as a JPA entity. For example, we're going to use @entity annotation. So make sure that you choose entity annotation from javax.persistence package. Now this entity becomes JPA entity. Okay, alright, now we are going to provide a table name. So for that, let's use @table annotation. So @table annotation has a property name, and we are going to use name attribute to provide a table name. So I am going to give table name as employees. Okay, great. So if you don't provide @table annotation, then JPA is not enough to provide table name as a name of the class. So name of the class is employee. Okay, great. So remember these important annotations. Now we are going to define a primary key for this table. So for that, we are going to use @id annotation. Make sure that you choose ID from javax.persistence package. So once we create a primary key, we will need to also generate a primary key generation strategy. For that, we are going to use @generated_value annotation. So let's pass attribute called strategy, and let's provide a value as identity. Okay, great. Now once we define a primary key for our table by using JPA annotation, let's define column details for these fields. So JPA provides @column annotation, which we can use to provide column name details. For example, here I am going to provide a column name for first name as post_name. Alright, this is how we map a field to column by using @column annotation. We can also define our column as a not null by using null label attribute. Okay, we can just pass false as a value to make this column as a not null. It's pretty simple, isn't it? Now similarly, we are going to provide column details for last name. Just give column name as last_name, and this is @column annotation, right? Okay, perfect. Similarly, let's give column name for email field. Let's use @column annotation with name attribute email. Alright, it's perfect, right? Very simple. So make sure that you understand the usage of these important JPA annotations. So this is a very simple employee JPA entity with fields ID, first name, last name, and email. Alright, great. Now what we're going to do is we're going to run our Spring Boot application, and we'll see whether this employees table will create in our database or not. Let's run our Spring Boot project. So Hibernate will automatically generate this table because we have added a property, that is DDL auto property in application.properties, right? So Hibernate will automatically create table by looking into that property. Okay, great. So look at here, Hibernate uses MySQL dilate to generate MySQL queries, and our application is up and running. Alright, let's head over to MySQL Workbench and let's verify whether table is generated or not. Go to EMS database and tables, and there we go. Employees table is successfully auto generated by Hibernate. Perfect, right? We have successfully created employee JPA entity. Now it's time to create employee repository. So we create an employee JPA repository because we need a CRUD operation to perform on employee JPA entity, right? So go to a repository package, and within repository package we are going to create an interface called employee repository. So remember, this is the interface, and this interface we need to extend to JPA repository. So JPA repository, it requires two parameters. First parameter is type of the entity. For example, in our case, we need to provide employee as a JPA entity. Second parameter, type of the primary key, that is long. If we can go inside employee JPA entity, you can see here the type of the ID is long. So this is the data type that I have provided. Okay, great. Now our employee repository will get CRUD methods for employee JPA entity. And here we don't have to add repository annotation to our employee repository interface, because JPA repository internally provides add repository annotation. For example, so JPA repository's interface, and let's look at its implementation class, that is simple JPA repository. If you go inside simple JPA repository, then you can able to see that it has already annotated with add repository annotation. Hence, we no need to add repository annotation again on our repositories. Alright, so this is very important, just note down. Simple JPA repository implementation class internally provides add repository annotation, so we no need to add repository annotation. So one more important is, so look at here, add transactional annotation. So JPA Spring Data JPA internally provide transactional for all its method. So again, we no need to add transactional annotation in service layer. That I will show you once we implement service layer. Okay, great. So just remember these points. So before building REST APIs, first we're gonna create one custom exception, that is a resource not found exception. So whenever a resource not exist in database, or whenever a record not exist in database, then our REST API should return to the client saying that this resource is not exist in database with given ID. So for that, we are going to create a resource not found custom exception. So go to exception package, new, and then choose class, and let's give class name as resource not found exception. Okay, great. So this is the very important, guys. So whenever there is an exception occurred in our Spring Boot application, we should handle it right. For that, this is the custom exception. So let's go and let's define few of the properties for this class, that is private string resource name. So we are going to return a resource name that not exist in database to the client. For that, we have used resource name here, and the field name and the field value. So these are the important properties. Perfect. So let's give object, because the field value can be any type, right? Perfect. Now let's go and let's extend our class from runtime exception, extends runtime exception. Okay, now what we're going to do is we're going to generate a constructor for these fields. Right click, source, and then generate constructor using fields, and select all these fields. Click on generate, and now we are going to pass a message to the superclass constructor. So look at here, we are going to pass the message something like a resource not found with field name and field value. So this is the proper message format. So we are using format method of string class here just to format the string. So here resource name is by dynamically passed here, and this placeholder will replace field name, and this placeholder will replace field value. Okay, simple. And here we are going to use just a getter methods. For example, get a resource name and generate get field name, and followed by generate get field value. Alright, and it needs to have a default serial ID, so let's generate by using Eclipse ID the serial version ID by using Eclipse ID here, and we're gonna use here the annotation called at response status annotation. So you can add this at response status annotation on top of REST API as well, but instead of repeating this annotation for each and every REST API that returns a status, what I'm going to do is I'm going to add this response status annotation on this exception class itself. Okay, and just define value as HTTP status not found dot not found. Okay, so whenever our REST API throw resource not found exception, then the REST API will basically send not found HTTP status to the client. Next step is we are going to create REST endpoints. So first we're going to create employee REST API to save a data into employees table. So for that, first we're gonna implement a service layer, because controller layer depends on service layer. So go ahead and first create interface and classes in service layer. So go to service.impl package here, right click on it, new, and then choose interface, and look at here, we are going to create this service, the interface, that is employee interface inside service package. So just remove here .impl, okay, and just give interface name as employee service. So make sure that you create this employee service interface inside Spring Boot service package. Hit finish. Now you can see here employee service interface is created within a service package. So now we are going to create a class which implements employee service interface inside service.impl package. So right click on this package, new, and then choose class, and let's give class name as employee service impl. So this is a naming convention we typically use to provide a service class name. So it means that the employee service impl is a class which implements the employee service interface. So impl stands for implementation. Okay, and now we're going to implement the employee service interface. And whenever you create a service class, then make sure that you will add at service annotation. Okay, make sure that you choose add service annotation from org.springframework.stereotype.service package. Alright, now our service layer is ready. Okay, now what we're going to do is we're going to define one method, that is save employee method, and the return type of this method is employee, and the name of the method is save employee, and the argument we're going to pass is employee object. Now we have defined the method in employee service interface. Now we are going to implement this method in employee service impl class. So go ahead and click on add unimplemented methods. Okay, so before implementing this method, we need to inject the dependency, right? That is employee repository dependency. So basically there are two types of dependency injection. One is setter based dependency injection, and another is constructor based dependency injection. So always remember you use constructor based dependency injection whenever you have a mandatory parameters, and use setter based dependency injection whenever you have optional parameters. So now in our case, we're gonna use employee repository as a mandatory, so we're gonna use constructor based dependency injection. So just create private employee repository object here, employee repository, and as we are using constructor based dependency injection, so right click, source, and generate constructor. And one more important thing is we don't have to again add auto add annotation, because whenever Spring Spring finds Spring Bean, it has only one constructor, then by default Spring will configure this dependency automatically. We don't have to add to add annotation for this constructor here, because whenever we have Spring Bean, it has only one constructor, then Spring Boot will automatically auto wire this dependency. We don't have to add to add annotation. So remember these things, or just note down these things. These things are really matters. Okay, so 3 important things are, just note down these points. You don't have to add repository annotation for this employee repository interface, because Spring Data JP already take care by adding add repository annotation. This is the first important point. Second point is, you don't have to add transaction annotation here, because Spring Data JP internally provides a transaction to all its methods. Alright, and the third important is, we don't have to add to add annotation to this constructor, because whenever Spring Boot finds Spring Bean, it has only one constructor, then Spring Boot will automatically auto wire this dependency. Okay, great. Now next is what we're going to do is, we're going to simply use employee repository and its method called save, and we're going to save employee instance to the database. So this completes our service layer changes for save employee or create employee REST API. Now what we're going to do is, we're going to create a REST API in controller layer. So go ahead and right click on controller package new, and then choose class, and here we're going to provide a class name as employee controller, and let's annotate this controller class with @REST controller annotation. So you can also use @controller annotation, but in case of @controller annotation, you have to use @response body annotation on top of each and every REST API that we define inside this controller. So in order to simplify that, Spring has provided @REST controller annotation, and this annotation internally uses @controller annotation as well as @response body annotation. Well, now we are going to inject the dependency, that is employee service. So as mentioned earlier, like, we are going to use constructor based dependency injection. So right click here, source, and then generate constructor using fields. Okay, and let me write the comment here: build create employee REST API. Okay, just create a method here. Method name is public, and the return type of the method is a response entity. Okay, so I will tell you why I am using response entity as a response type here. And this is a generic class, so I want to pass employee object. Okay, and just give method name as save employee. Alright, so why I am using response entity class, because we can provide complete response details in this class. For example, we can add a status to this class, header, etc. So that's why I'm using response entity class here to generate a response for this REST API. Okay, now let's go and let's annotate this method with @post mapping annotation. So here we are using @post mapping annotation because this REST API should handle post HTTP request. Now here we want to pass the employee object, because this post request contains a employee JSON object, right? And that we need to bind to the Java object, that is employee object. For that we are going to use annotation called a request body annotation. A request body annotation. Now we need to return this object, right? That is response entity. So just return new response entity, and here we are going to use this response entity overloaded class. So look at here, there are overloaded constructor for a response entity class, right? We are going to use third one because we need to pass the body and the status. So body is employee object, so we are going to just call a save employee method and we just pass the employee object, and here again second parameter we need to pass the status, right? So in this case the HTTP status is created. So this REST API will create the resource. That's the reason we are going to pass HTTP status as created. I'm gonna add here add request mapping annotation, and I want to provide the base URL for this controller, that is API/employees. So we can define this employees URL here as well, but in order to maintain this employees URL in a common place, so I'm gonna add here in a base URL itself. Okay, I just remove this. Okay, just save this file, and now we are going to run our Spring Boot application and test this REST API using Postman REST client. So go ahead and run our Spring Boot application now. Right click, run as Spring Boot application. So make sure that you have installed Postman REST client because we are going to use Postman REST client to test the REST APIs. Well, our Spring Boot application is up and running. So let's head over to Postman REST client. Okay, and just type the URL http localhost followed by the port 8080/API/employee. So this is our REST endpoint URL, and we are going to test post REST API, that is save employee REST API. For that we need to pass the JSON in a request body, right? For that we need to choose the HTTP method, that is post, because we are sending post request, and go to the body. We are going to define a JSON here inside a body. So go to body and then choose raw here, and here we are going to create a JSON. So first name, let's say Ramesh, and last name Fadtare, and email ramesh@gmail.com, and make sure that you choose content type JSON here. Alright, so once you configured everything successfully, so look at here, this is the syntax error, comma is missing. Okay, once you configured everything, then go ahead and click on send, and there we go. So employee is successfully inserted in database, and we got a success response from the REST API with status code 201 created, and this is the response, and ID here, so ID equal to 1, so this is the auto generated primary key value. And let's head over to the MySQL workbench, and if you can see, a record is inserted in a database table. Alright guys, we have successfully implemented save employee REST API. Now we have built create employee REST API to save employee data to the database. Next, we are going to create get all employees REST API to retrieve all the employees from the database table. So go to employee controller again, and within employee controller we are going to build get all employees REST API. So let me write the comment here, build all employee, that is get all employees REST API. Okay, great. So before creating this REST API in employee controller, so employee controller depends on employee service. Alright, so this controller layer is depends on service layer. So first we're gonna make changes in service layer. So go to service package, go to employee service interface, and here we want to define a method called get all employees method, and the return type of this method is list of type employee, and just give method name as get all employees, and we don't have to pass any parameter to this method. Go to employee service IMPL class and just click on add unimplemented methods. Now we are going to implement get all employees method within a employee service IMPL class. So get rid of these comments, and we are going to simply return employee repository, and we are going to call its method called find all method. So look at here, find all method returns list of employee. Okay, so go ahead and just call this find all method here. So that's it, we have done a changes in a service layer for get all employees REST API. Let's get back to employee controller, and now we are going to build a REST API. So just create a method here, public, and then the return type of this method is list of employee type, and just call this method as get all employees. Alright, now this is a simple method, so let's make it as a REST API by annotating this method with get mapping annotation. So this REST API is going to handle get HTTP request. That's the reason I have provided add get mapping annotation. Now what we're going to do is we're going to simply return here, return, and then call employee service object. It has get all employees method. So go ahead and call get all employees method, which returns a list of employees. Now let's test get all employees REST API by using Postman client. Let me quickly start the Spring Boot application. Alright, our Spring Boot application is up and running. Let's head over to Postman REST client, and I'm going to insert few more records before testing get all employees REST API. So let me insert one more employee, post name John, second name Sina, and email ID let's say sina@gmail.com, and hit send button. Okay, second employee is inserted successfully in a database, and we also got the response. So let's go and let's insert one more employee. Let's say Tony Stark, and Tony@gmail.com. Hit send button, and there we go. So we have inserted 3 employees in a database. Let's verify it. And there we go. So there are 3 employees in an employees table. Now we're gonna test get all employees REST API. So for that I'm going to create a new request and just type http localhost 8080/API/employees, and make sure that you choose http get method over here, and go ahead and hit send button, and there we go. So look at here, in a response we got array of objects, right? Array of JSON objects. So we got all the employees from the employees table in a database. Alright, it means that we have successfully built get all employees REST API. Alright, great. Now let's go ahead and let's build get employee by ID REST API. So get all employees REST API will return all the employees, right? Okay, so get all employees REST API will return all the employees to the client. Now we are going to build a REST API which will return specific employee with given ID. Okay, we are going to build get employee by ID REST API which will just return a particular employee by ID to the client. So go to employee controller again, and let me just write the comment here: build get employee by ID REST API. And we are going to follow the same steps like controller layer is depends on service layer. So first we will make a changes in a service layer and then we will get back to controller layer. So go to employee service, and here we are going to define a method again in the interface. So the return type of the method is employee, and the method name is get employee by ID, and we are going to pass ID as a method argument to this method. Okay, and go to employee service IMP class, and we are going to implement this method over here. So here what we're going to do is we're going to simply fetch employee object from the database by passing ID. So this is employee equals to, we're going to use the employee repository here, and it has a method called find by ID method, right? Yeah, find by ID, and we're going to pass ID. And look at here, find by ID method returns optional. Okay, optional object. So we are going to store a result of find by ID in optional object. So what I'm going to do is I'm going to simply call here optional. So make sure that you choose optional from java.util package, and this is generic, so we pass type as an employee. Alright, now what we're going to do is we're going to simply check whether this optional object contains the employee object or not. For that we're going to use if condition here. If employee dot is present, then what we're going to do is we're going to simply return employee dot get. Okay, so get method basically returns content of this optional object. So else what we're going to do is we're going to simply throw the resource not found exception. Resource not found exception, and look at here, the resource name is employee and the field name is ID and the field value is ID. That's it, and it internally creates a message, right? So look at here, this is a message, employee not found with ID and then ID value. It will create a proper message and it will pass to runtime exception, and runtime exception will throw this message in a console. Okay, perfect. So let's get back to employee service IMPL. That's it. So instead of using if else here, you can also use lambda expression. So let me also show you that approach. So let me just comment out this code, and we simply return employee repository dot find by ID, and then we pass ID here. It returns optional, so optional has a method called or else throw method. Okay, so we're going to use or else throw method to throw the exception if resource not found in database. And if you can just mouse over on or else throw, so this method, look at here, it uses supplier functional interface, and we're going to use a lambda expression to implement supplier functional interface. And look at here, this is the syntax for lambda expression. New resource not found exception, and we're gonna pass argument to this constructor. So post argument is the resource name, that is employee, and second argument the field, that is ID, and third argument is field value. Alright, it's pretty simple, isn't it? So instead of writing these line of code, these number of lines of code, we can in a single statement we can write this logic by using lambda expression, and this is the preferred approach. So whenever you have opportunity to use Java 8 features like lambda expression or functional interface, then make sure that you will use these features. Perfect. Now once we complete the service layer, let's head over to employee controller. Now we're going to build a REST API, right? So just type public. We're going to first create a method, and then we make this method as a REST API by annotating add get mapping annotation. So again we are going to use add response entity as a return type, and we are going to pass employee as a type. Okay, and the method name is get employee by ID. Okay, and let's annotate this method with add get mapping annotation. Okay, and we are going to pass ID here, that is long ID, and from the client the REST API should get ID, right? So for that, what I'm going to do is I'm going to configure here a path variable within a curly braces, just give ID. Okay, now in a path variable, this is basically a URL template variable. Okay, for example, if our REST API, the client uses the REST API URL like this, localhost /API/employees/1. Alright, this ID is dynamic. Okay, this one the path variable is dynamic, so we can pass any ID here, 1 2 3 etc. So that's the reason we are going to provide this ID within a curly braces here. So this is the syntax to get a path variable, and path variable is dynamic. Okay, and we are going to retrieve a employee with ID 1 in this example. Alright, now this URL template variable has a value 1, so we are going to get a value from this variable, path variable. For that, what I'm going to do is we're going to use add path variable annotation. Okay, so here I'm going to use add path variable annotation here, and the name of the variable is ID, right? So we are going to pass here ID. So whatever you name give here in a path variable, that you should give here as well. Okay, and this ID name can be different. Okay, for example, I can give employee ID. Okay, this ID should match this one and the ID which we passed to add path variable annotation. Perfect, isn't it? Now we are going to return response entity object. So for that, I am going to call return here new and then response entity, and we are going to call this overloaded response entity constructor here, because it takes body as well as status. So just call employee service, and it has a method called get employee by ID, and just pass the ID here, that is employee ID. And in this case the HTTP status is 200, that is okay. That's it. Pretty simple, isn't it? So get employee by ID REST API just returns I employee to the client with status code okay. Perfect. Now what we're going to do is we're going to run our Spring Boot application and we test this REST API using Postman client. So go to Spring Boot backend application. So this is a main Spring Boot application class. So we are going to run this class now. So make sure that you will stop the existing instance of the server. So just start Spring Boot application now. Alright, our Spring Boot application is up and running now. Okay, now let's head over to Postman REST client and we're going to test get employee by ID REST API. So in order to test get employee by ID REST API, I'm going to create a new request. So click on plus icon here and just type http localhost 8080/API/employees and make sure that you choose add get HTTP method, and we are going to retrieve a particular employee with ID 1. So we are going to pass /1 here and hit send button, and there we go. The REST API return this employee object with ID 1. Alright, it means that get employee by ID REST API is working as expected. Now if you try to retrieve an employee with ID 2, here we need to just pass a 2, ID as a 2 here, and just hit send button, and there we go. The client got a response that is the employee with ID 2 and the status code 200. Okay. Alright, it means that we have successfully implemented get employee by ID REST API. Now we are going to implement update employee REST API. So go to employee controller, and here I'm going to write the comment here, build update employee REST API. So we're going to follow the same steps like controller layer depends on service layer. So first we're going to change service layer and then we get back to controller layer. Okay, go to employee service interface, and here we're going to declare a method. The method returns employee object and the method name is update employee, and we're going to pass the first argument as employee object and second argument as the ID of the employee class. Okay, once we declare update employee method in employee service interface, then we are going to implement this method in employee service IMPL class. So go ahead and click on add unimplemented methods here, and here we are going to implement update employee method. So get rid of this comment here. Okay, so now what we're going to do is we're going to first check whether the employee with ID is exist in a database. So let me write the comment here. So first we need to check whether an employee with given ID is existing in database or not. Okay, so for that what we're going to do is we're going to define the employee here. Let's call this as existing employee, existing. Okay, and we're going to use employee repository. It has a method called find by ID, right? So just call find by ID method and just pass the ID here. Now we got a employee with ID. So find by ID method returns optional object, right? So what we're going to do is we're going to simply call or else method of optional object or else. Okay, if employee object with given ID is not existing in database, then we are going to simply throw a resource not found exception. Okay, so let me write the lambda expression here. New resource not found exception, and the first argument is the resource name, that is employee. Second argument is the field name, that is ID, and third argument is the field value, that is ID. Now we have checked whether an employee with a given ID is exist in database or not by using this statement. So if employee is not exist in database, then it simply throw the resource not found exception. Now what we're going to do is we're going to update this existing employee from the employee. So this is the employee we got from the client, right? Now we're going to update all the details from this employee object to existing employee object. Existing employee dot set, we're going to update first name, so let's call set first name, and employee dot get first name from the employee object, which is provided by client. Similarly, existing employee dot set last name, and we're going to get last name from the employee object get last name method. Let's call existing employee dot set email, and we are going to get email from employee object by using get employee method. So once we set all the updated employee details to existing employee, then we are going to save existing employee to database. So just call employee repository, it has a method called save, and we're going to pass existing employee object to it. Perfect. So now we simply return this existing employee to the controller layer. Pretty simple, isn't it? So once we done all the changes in a service layer, let's head over to the employee controller now, and here we're going to create a method public, and the return type of the method is response entity, and we're going to pass type as employee, and the method name is update employee. Okay, alright, now this is the method, and we need to make this method as a REST API by using at put mapping annotation. So client sends a put HTTP request, and this REST API should handle put HTTP request. For that we are going to use at put mapping annotation here. Alright, and the client uses the URL like this to call this update employee REST API. So it will pass ID of the employee that this REST API want to update. For example, if we want to update employee with ID 1, then we need to pass ID 1 in a URL, and also the information that we need to update in a request body. Okay, so this is the one, so this is ID, so we need to handle this ID by using path variable. So let's, within a curly braces, let's add ID here. So this is a path variable, and this can be dynamically changed, so that's why we have added in a curly braces. So this is the syntax to bind the path variable value. So in order to bind in order to get a value from this ID, what we're going to do is we're going to use add path variable annotation, add path variable annotation, and in order to map this string, that is ID, so we're going to pass simply ID here, and we need to store a value in some data type, right? Some data, some variable, that is long ID. Now we got a value that is 1 from the URL. Now we are going to store update employee REST API request body in some object. So for that, again, what we're going to do is we're going to use here employee object, and in order to convert the request body contains JSON, right? We need to convert that JSON into Java object. For that we're going to use at request body annotation. Pretty simple, isn't it? So pretty simple. Just we need to get the JSON object from the request body. For that I have used at request body annotation here, and in order to get a path variable I have used at path variable annotation. It's pretty simple. And now what we're going to do is we're going to simply return an instance of response entity class, and make sure that you choose response entity. That is response entity. It has two parameters, body with status, and here we're going to pass a body as employee service dot update employee, and just pass employee object as a first argument, id as a second argument, and http status. Okay, that's it. Pretty simple, isn't it? Perfect. So look at here, we have used response entity as a return type, because response entity we use to prefer response of the REST API. We can add status to this class, we can add a body to this class, and we can add header, etc. So in order to create a complete response for this REST API, we are going to use a response entity. Okay, just remember why I am using response entity as a return type of the REST API here. Now let's go ahead and let's test this update employee REST API. So let me stop the existing server and let me start fresh Spring Boot application. Alright, our Spring Boot application is up and running on embedded Tomcat server on port 8080. Let's head over to Postman client, and in order to test update employee, let's create a new request. Click on plus icon here and just type the URL http localhost 8080/API/employees, and make sure that you choose put HTTP method here, and make sure that you need to pass the ID of the employee that we are going to update. For example, 1. So we are going to update employee with ID 1. Go to the body and go to the raw, and here we are going to prepare a JSON. So go to the post request and quickly copy this JSON and paste here inside the body. And if you look at the database, employee with ID 1 has first name Ramesh, last name Fadtare, and email ramesh@gmail.com. Now we are going to update first name and email. For example, first name, now it has a Ramesh, right? So instead of Ramesh, we store Ram, and email ram@gmail.com. Okay, so first name Ram, second, let's say last name, let's change from Fadtare to Jadhav, and also change email from ramesh@gmail.com to ram@gmail.com. Go ahead and click on send, and look at here, we got a response like unsupported media type. So make sure that you choose JSON as a content type here, otherwise you will get a response like this. So go ahead and click on send button now, and there we go. The employee with ID 1 is successfully updated. So look at your first name, last name, email is successfully updated. You can also verify in a database. So existing first name, last name, email is like this. If we refresh, we can able to see here first name, last name, and email is updated for this employee with ID 1. Or it means that we have successfully built update employee REST API. Now let's build delete employee REST API. So go to employee controller and just let me write the comment over here. Build delete employee REST API. Okay, So we are going to follow the same steps. Like controller layer is depends on service layer. So first we'll make a changes in service layer and then we'll get back to controller layer. So go to employee service interface, and here we are going to define a method called delete employee, and we are going to pass id to this method as a method argument. Let's go to employee service IEmployee class to implement this method, and click on add unimplemented methods and get rid of this comment. Okay, and just call employee repository. It has delete by id method, right? And we are going to pass id to it. So this will delete a employee from the database with id, with a given id. So look at here, let's say if id that client passes is not existing database. Okay, we need to handle that, right? So let's say if client pass id 5 and the employee with id 5 is not existing database, then we need to throw the exception. Okay, so first, before calling delete by id method here, so first we need to add a condition here. Check whether an employee exists in a database or not. For that, what we're going to do is we're going to simply call employee repository, and it has a find by id method. We're going to call find by id method and we pass id to it. So this find by id method returns optional object, right? And this optional object has or else method, so we are going to use or else throw method here in order to throw the exception if employee with id is not existing database. So similarly here we are going to write the lambda expression, resource not found exception, and the resource name is employee, second argument id, third argument value, that is id. Pretty simple, isn't it? Perfect. So before deleting employee from the database, we add a condition here whether an employee is exist in DB or not with a given ID. If the employee is not exist in a database with a given ID, then it will throw the resource not found exception. Okay, and the REST API will return this message to the client. It's pretty simple, isn't it? Now we have changed service layer. Let's head over to employee controller now, and here we are going to simply write the method public, and the return type of the method is response entity, and just pass type as a string, and the method name is delete employee. Okay, now it is a method. Let's make this method as REST API by adding delete mapping annotation here, and again the request, that is REST endpoint variable for this REST API is like this. Okay, so client uses this REST API endpoint variable to delete the employee, and here look at here, one is nothing but employee ID. Okay, now we are going to handle this request. Okay, so one is nothing but a path variable, so we are going to use curly braces, within a curly braces id. So this is the syntax to handle a path variable. Okay, now we are going to get a value from this path variable, so let's use add path variable annotation, and this is id, and we need to store in some variable of type long here. Okay, perfect. All right, now what we're going to do is we're going to call delete employee method of employee service class to delete the employee. So go ahead and call employee service dot delete employee and just pass the id. So this will delete employee from database. So once we delete employee from database, then we should return a success response to the client, right? For that we are going to return here response entity. So make sure that you choose a response entity with two parameters, body and status. Okay, and the body we can give like employee deleted successfully, something like this. And HTTP status we can give okay. Perfect, right? So that's it. We have built delete employee REST API. Now we are going to test this REST API. Alright, so go ahead and stop the existing server. Okay, go to Spring Boot main entry point class, right click, run as Spring Boot app. Okay, our Spring Boot application is up and running. Now let's head over to Postman client and click on plus icon, because we are going to create a new request to test the delete employee REST API. Just use http localhost:8080 API/employees followed by employee ID. So we are going to delete a employee with ID 1, so that's the reason I am passing 1 here. And make sure that you choose http delete method here. That's it, and go ahead and click on send button, and there we go, employee deleted successfully with status code 200. Alright, it means that we have successfully built delete employee REST API. Now let's head over to database and let's verify whether the record is deleted or not. So go ahead and right click on the table, select rows, and there we go. So employee with ID 1 is deleted. Now let's go and let's delete employee with ID 2. Hit send button, and there we go, we got a success response. Head over to database and execute select query, and there we go, employee with ID 2 is successfully deleted. Alright guys, we have successfully built CRUD REST APIs for employee resource. We have built create employee REST API, get all employees REST API, get employee by ID REST API, update employee by ID REST API, and delete employee REST API.